So today we are going to see two chapters from pharmaceutical engineering. First one is your distillation, which is remained. Second one is your crystallization. First, what do you mean by distillation? Is nothing but it is a separation technique. Okay, as like other separation techniques. जैसे आप बाकी का separation technique होता है. Drying में भी आप separate कर रहे हो ना, water को separate कर रहे हो. Evaporation में भी आप water को separate कर रहे हो. So like that, in distillation also it is a separation technique. Okay, but it is not a complete it is not a complete separation technique, it is a partial separation technique. What is meant by distillation? Distillation means separation of mixture by converting it into, so vaporization of, so distillation means vaporization of mixture of liquid and then subsequent condensation of vapor at another place. That is nothing but the distillation. So distillation is nothing but the, it is a vaporization of mixture of two liquids and subsequent conversion of that vapors into condensate at another place. That is nothing but the, so general assembly for distillation will look like this. So here you will have a distillation flask. This one is nothing but the this one is nothing but the condenser. This one is nothing but the distillation chamber, and this one is a receiver. So whatever the mixture you are going to distillate, the distillation mixture is known as distillant. तो जो डिस्टिलेशन के लिए मिक्सचर ले रहे हैं आप, जैसे मान लीजिए कि वाटर है आपका और अल्कोहल है. सो इफ वाटर अल्कोहल मिक्सचर इज देयर, so you want to separate the alcohol from water, so by distillation, so the mixture of water alcohol is nothing but the distillant. Okay, this is a distillant. Then this is temperature control over here. So you can see the thermometer which is attached to a this distillation column. This is known as a distillation column. This is a distillation flask, and distillant is added in this. So here vaporization of mixture takes place by the application of heat. So this vapor will be there due to difference in the volatilities. So water will have a different volatility and your alcohol will have a different volatility. In the other terms, you can say that alcohol has a different boiling point, water has a different boiling point, and because of difference in the boiling point, so it is achieved, separation can be achieved due to difference in the boiling point or difference in the volatilities. Okay, now the mixture which the component of mixture which is having less boiling point, जो जिसका boiling point कम है, ये वेपराइज होने के बाद वो जल्दी वेपराइज हो जाएगा और वो वेपर्स पास होंगे यहाँ से, यहाँ पे कूलिंग होता है. सो दिस इज अ कंडेंसेशन. So inlet for what inlet for water and outlet for water. So there here will be condensation will take place. You will get your distillate. So whatever product after distillation is known as a distillate, and the product mixture for distillation is known as distillant. Now we'll see what is distillation. So distillation is the separation of component of liquid mixture, process involving the vaporization and subsequent condensation at other place. It is considered as a partial separation method. It's not a complete separation method, because इसमें क्या होता है कि दो जो मिक्सचर है उसका अगर आपने वेपराइज किया, अगर उसका बॉइलिंग पॉइंट डिफरेंट है, मतलब बहुत ज़्यादा डिफरेंस है उसमें, एक का 85 है, एक का 95 है, या फिर एक का 120 है. So there is a huge difference in between the boiling points of two component of mixture. In that case, the distillation is considered as a complete separation method. Suppose that your two component of mixture has a similar boiling point. For example, 95, एक का है 95 डिग्री सेल्सियस और एक का है 96 डिग्री सेल्सियस. So there is a little bit difference between boiling point of these two components. So what happens in that case? In that case, the whatever vapors are coming, so that vapors also consist of a vapor are nothing but the mixture. So component having less boiling point will have a higher composition in the vapor. Along with that, another component which is having boiling point little bit difference. So it will also have component in that. So it is just a mixture. So whatever distillate you are getting, so distillate will get some amount of component A and component B. Mostly the less volatile or more volatile जो component है उसका ही amount ज़्यादा मिलेगा distillate में, लेकिन जो less volatile है उससे थोड़ा सा कम है. As there is no big difference between the boiling point, उसके वोलेटिलिटी में ज़्यादा कोई डिफरेंस नहीं, तो कुछ प्रोपोर्शन में वो भी आ जाएगा. मतलब प्योर डिस्टिलेट you cannot get a pure distillate if the mixture is of two component having very narrow range of boiling point. So it is considered as a partial method for separation. So that's why it is a partial method. So again, distillation is a separation of components of liquid mixture by process involving the vaporization and subsequent condensation at other place, and it can be considered as a partial method for separation. Now when condensed vapor are required, you use a distillation process. When condensed vapor are required as a product, you use distillation process. And when concentrated liquid residue is needed, is required as a product, then we use evaporation. So in the distillation, the solution is heated to form a vapor. Solution means mixture of two components. So in distillation, solution or mixture is heated to form a vapor of more volatile component. Vapor of more volatile component in the mixture. The vapor are then cooled, condensed and collected as a liquid drop or a drop of liquids. By repeating the vaporization and condensation of mixture, by repeating the same procedure, that is vaporization and condensation of mixture, a liquid can be separated by separating individual component in pure form. By single distillation, you cannot get a pure form of compound. But by repeating the condensation, by repeating the vaporization and condensation, so by repeating the procedure और by using a fractionating column, जो fractionating column होता है उसमें ये process repeat होता है. Means there will be partial evaporation, there will be partial condensation, again partial evaporation, again partial condensation. So in the fractionating or fractional distillation, or by using fractionating column, you can get a pure compound and in a distillate. But in the simple distillation, you cannot get a pure distillate. So that is the major difference. So in distillation, solution is heated to form a vapor. So you have mixture in the mixture of liquid in the your solution. Now these two mixtures will have different volatility and different boiling point. So the compound which is having less boiling point will be converted into vapor first to form a vapor of more volatile component in the mixture, and then vapors are cooled, condensed and collected in the form of liquid, that is known as a distillate. And by repeating this process, vaporization and condensation, you can get mix, you can separate the mixture in a pure form. Separation is achieved because of differences in the volatilities. See, your mixture has mixture A, your solution or mixture has a component A and component B. Now these two component must have a little bit difference in the volatilities. Then and then only you can separate them by using distillation. So if they don't have any difference in the volatilities, if they don't have any difference in the boiling point, so it is not easy to separate that mixture by using distillation. So separation is achieved or it is achieved because of the difference in the volatilities of components. So okay, so two components of mixture at a given temperature and pressure, two component of mixture at a given temperature and pressure, they will have difference in the vapors and liquid composition at equilibrium due to components of partial pressure of each and every components. ठीक है, so component A and component B partial pressure अलग होगा. So because of that, so जिसका partial pressure ज़्यादा है तो उसका वेपर जल्दी हो जाएगा, जिसका partial वेपर pressure कम है तो उसका वेपर कम हो जाएगा. So जिसका partial वेपर pressure ज़्यादा है वो जल्दी यहाँ से वेपराइज हो जाएगा और डिस्टिल आउट हो जाएगा. So that is because of the separation is also because of the difference in the volatility, because difference in the volatilities of individual component. Two components of mixture at a given temperature and pressure, there will be difference in the vapor due to difference in the volatilities of component, or due to difference in the partial pressure of. So that is the applications of distillation. What are the applications of distillation? We'll see step by step. First we'll see the application, then we'll see the theory behind the distillation properly, the laws involved in the what is Raoult's law, what is Dalton's law, and then so first application of distillation. So first one is the separation of volatile oil. By using steam distillation, you can separate a volatile oil from your crude drugs. For example, if you want to isolate eucalyptus oil, so steam distillation is used. If you want to isolate the clove oil, then again steam distillation is used. If you want to isolate a anise oil, then again steam distillation is used. That is for separation of volatile oil. इसके ऊपर कभी कोई क्वेश्चन आ सकता है. Isolation of volatile oil from crude drug involves one of the following distillation, one of the following type of distillation. So steam distillation. Different type of distillations are there. This is steam distillation, simple distillation, distillation under reduced pressure, then molecular distillation, fractional distillation, then azeotropic distillation. So there are different type of distillation. So you have to remember separation of volatile oil from crude drug, that involves the steam distillation. Okay. Second application, purification of organic solvents. So purification of organic solvent. Purification of organic solvent is done by different method like simple distillation. Okay, simple distillation is used to purify the organic solvent. जैसे मान लीजिए कि आपके बेंजीन है, बेंजीन में अगर कोई इम्प्योरिटी आता है, बेंजीन के नियर अबाउट कौन सा है, केरोसिन है, केरोसिन और बेंजीन का मिक्सचर है. सो यू वांट टू सेपरेट benzene pure in a pure form. So obviously distillation, simple distillation is used. If there is a difference between the boiling point of two mixture, okay, then azeotropic distillation is used to prepare the absolute alcohol for the purification of organic solvent. So alcohol always comes with the water. So water is always present as an impurity in the alcohol. Okay, so whatever alcohol you are using in your lab, they are not a absolute alcohol. They are they are just the 90% alcohol. 10% water will be always there. So to remove that 10% alcohol, azeotropic distillation method is used, so that you will get alcohol in a pure form. That is 100% alcohol. That is known as a absolute alcohol. इसके ऊपर क्वेश्चन आ जाता है GPAT में. So to prepare an absolute alcohol, one of the following, that is nothing but the azeotropic distillation. What is it? What is azeotropic solution? What is azeotropic mixture? What are the zootrop? What is azeotrop? We will discuss in the upcoming slide. So just remember, the azeotropic distillation is used for the to prepare for the preparation of absolute alcohol. It is 100% yield. And manufacturing of official preparation. So there are preparation like distilled water IP, water for injection IP, water for injection BP, aromatic spirit of ammonia. Different official preparations are there, which are mentioned in the Indian pharmacopoeia as well as other pharmacopoeia. So for to manufacture those official preparation, you need a distillation. So using distillation, water for distillation, distilled water is prepared, water for injection is prepared distillation. So that was the third application. Fourth application, refining of petroleum products. So whatever crude oil is there, from crude oil you can get different petroleum products. From crude oil, by distillation and purification, you will get the first grease and jet jet fuel, grease jet fuel you can get. Further purification, you will get a kerosene. Further purification of crude oil, you will get a kerosene. Again, further purification and further separation, you will get a diesel. Okay, and after further purification, you will get a petroleum ether. Further purification, you will get a petrol, and further purification, you will get a natural gas. That means refining of petroleum products. So from crude oil, you are getting here grease, then jet fuel, then you are getting kerosene, then you are getting diesel, then you are getting the paid ether, then petrol, and then finally natural gas. This distillation is again used for refining the petroleum products. Okay, recovery of solvent after extraction. So whatever extraction you are doing in your lab, for example, if you want to extract some alkaloids, glycosides, or if you want to extract some crude material, so you are using various kind of organic solvent like ether, chloroform, alcohol. So for the recovery of that product, you are using distillation. For quality control method, as a quality control method, so distillation can be utilized as a quality control method for the preparation which contain alcohols. So for it is used as a quality control method to determine the alcohol contained in the elixirs. So elixir is a dosage form, is a hydroalcoholic dosage form, potent drug. So that is nothing but to evaluate the quality or to determine the alcohol contained in the elixir. So distillation can be for the separation of drug obtained from plant and animal source after extraction. For example, extraction of vitamin E from cod liver oil using various kind of solvents, organic solvents. So to separate the drug from crude drug from animal and plant origin extraction. So again, distillation is and product obtained from chemical process. So see whatever the chemical reactions are there, synthetic reaction. So using distillation, separate the product from solvent. Now theory of distillation. So distillation is based upon the two laws. First law is Raoult's law. Second law is Dalton's law. So mostly distillation may be a different type. Say liquid मिक्सचर हो सकता है आपका, लिक्विड सॉलिड मिक्सचर हो सकता है आपका, लिक्विड गैस एंड गैसेस का मिक्सचर हो सकता है. तो separation of gases is also comes under distillation, but that is another way. But most of the pharmaceuticals, they are the mixture of two liquids. That's why we are just focusing on the mixture of two liquids. So Raoult's law is applicable for that. So what it states, the partial vapor pressure of each volatile constituent of a mixture is equal to the vapor pressure pure constituent multiplied by its mole fraction in the solution. इसका सीधा सीधा कहना ये है कि अगर मिक्सचर है मिक्सचर है आपके पास दो लिक्विड का मिक्सचर है, मिक्सचर है, तो उसमें क्या होगा, लिक्विड ए होगा, लिक्विड बी होगा. पार्शियल वेपर प्रेशर ऑफ ईच वोलेटाइल कांस्टेंट, उसका कहने का ये मतलब कि पार्शियल वेपर प्रेशर ऑफ ए is nothing but the vapor pressure of A in a pure form and its mole fraction. मतलब you can say, for example, partial vapor pressure of A is equal to vapor pressure of A in a pure form into its mole fraction. That is nothing but the Raoult's law. So again, it will state that a partial vapor pressure of each volatile constituent of mixture is equal to the vapor pressure of pure constituent multiplied by its mole fraction in the solution at a given temperature. That is nothing but the Raoult's law, which is the basis for the distillation. Remember, ये law, it is a law. This law is basis for the distillation. आपको याद होना चाहिए. So they might ask you a question like Darcy's law is related with, okay, Kirchhoff's law is related with, Etting's theory is related with, or in a one column they will give you a different law, another column they will give you this process like drying, evaporation, distillation, saturation, like that. So you should be able to find the correct match. So Raoult's law, what it gives the quantitative relationship between vapor pressure and concentration. तो इसने क्या बोला है कि partial vapor pressure of each volatile component is equal to the pure vapor pressure of pure component multiplied by its mole fraction, the solution at a given temperature. So it gives the relationship between the vapor pressure and concentration. Total pressure exerted by a system means mixture. Total pressure exerted by a mixture is equal to the sum of partial vapor pressure of its component. मतलब अगर आपके पास कोई मिक्सचर है, ठीक है, मिक्सचर ऑफ कंपोनेंट ए एंड बी, so the total pressure exerted by the mixture is equal to partial vapor pressure of component A plus partial vapor pressure of component B. That's it. So total pressure exerted by a system is equal to sum of the partial vapor pressure of its component. Now this Raoult's law is obeyed by ideal solutions. So ideal solution जो होते हैं, they obeys the Raoult's law. वो Raoult's law को obey करते हैं. Means क्या? So the vapor pressure of mixture is equal to the sum of partial vapor pressure of A plus partial vapor pressure of B. So that is obeyed by ideal. That is obeyed by ideal solutions. Okay. Those who do not obey the Raoult's law, they are known as a real solution. They are known as a real solution. So there is a deviation from this law, Raoult's law. So for example, according to Raoult's law क्या कहता है कि जो वेपर प्रेशर है मिक्सचर का, जो मिक्सचर है आपके पास, उसका वेपर प्रेशर क्या है, इट इज द सम ऑफ इंडिविजुअल पार्शियल प्रेशर ऑफ कंपोनेंट्स. मतलब आपके पास में मिक्सचर है, मिक्सचर ए प्लस बी का सॉल्यूशन है, तो उसका जो वेपर प्रेशर है वो कितना होगा, पार्शियल वेपर प्रेशर ऑफ ए प्लस पार्शियल वेपर प्रेशर ऑफ बी, इतना होना चाहिए, ऐसा राउल्ट्स लॉ कहता है. पॉजिटिव डेविएशन मींस व्हाट? सो देयर आर सम लिक्विड सिस्टम where the vapor pressure is greater than the sum of the partial pressure of individual component. There are the some liquid system where the vapor pressure of mixture is more than that of the sum of individual partial pressure of component. So this is nothing but the positive deviation. Positive deviation मतलब क्या? कि अगर कोई लिक्विड मिक्सचर है और उसका वेपर प्रेशर ज्यादा हो रहा है, किससे कि इंडिविजुअल वेपर प्रेशर से, अगर आपने एडिशन किया इंडिविजुअल वेपर प्रेशर का, उससे भी ज्यादा हो रहा है मिक्सचर का वेपर प्रेशर, so that is nothing but the positive deviation. Okay, so this was question in GPAT 2020. So positive deviation, when the vapor pressure of mixture is more than that of the sum of individual component, that is nothing but the positive deviation. Okay, so in some liquid system vapor pressure is greater than that of the sum of partial vapor pressure of individual components. This is a positive deviation. As it is line पूछा था कि if mixture, the vapor pressure of mixture is more than the sum of the partial vapor pressure of its component, then it is known as is positive deviation, negative deviation. like उसमें ऐसा option थे. So the positive deviation is, this was question in GPAT 20. Positive deviation to Raoult's law. So real solution will deviate from the Raoult's law. Ideal solution will obey Raoult's law. For example, कार्बन टेट्राक्लोराइड का अगर मिक्सचर है आपका, कार्बन टेट्राक्लोराइड एंड साइक्लोहेक्सेन, CCl4 प्लस साइक्लोहेक्सेन, कार्बन टेट्राक्लोराइड साइक्लोहेक्सेन का मिक्सचर है, तो इसका जो वेपर प्रेशर है मिक्सचर का वो ज्यादा होगा किससे, पार्शियल प्रेशर ऑफ कार्बन टेट्राक्लोराइड प्लस पार्शियल प्रेशर ऑफ साइक्लोहेक्सेन, उससे ज्यादा होगा. तो मान लीजिए कि ये मिक्सचर है आपके पास और पार्शियल वेपर प्रेशर ऑफ कार्बन टेट्राक्लोराइड इज 1, पार्शियल वेपर प्रेशर ऑफ कार्बन साइक्लोहेक्सेन इज 2. सो आइडियली मिक्सचर का वेपर प्रेशर होना चाहिए 3, वो 4 होता है. सो दैट इज नथिंग बट द पॉजिटिव डेविएशन. ओके, सो पॉजिटिव डेविएशन occurs with the कार्बन टेट्राक्लोराइड, साइक्लोहेक्सेन एंड बेंजीन एंड इथेनॉल. बेंजीन इथेनॉल का मिक्सचर अगर है तो वो भी पॉजिटिव डेविएशन दिखाएगा राउल्ट्स लॉ में. कार्बन टेट्राक्लोराइड साइक्लोहेक्सेन का मिक्सचर भी पॉजिटिव डेविएशन दिखाएगा राउल्ट्स लॉ में. आर यू गेटिंग और नॉट? समझ रहे हैं आपको? हेलो, दैट इज पॉजिटिव डेविएशन. नाउ नेगेटिव डेविएशन. Negative deviation means what? Exactly opposite to the positive deviation. So in positive deviation, the total pressure of the system was more than the sum of the individual partial pressure. So in case of negative deviation, it is opposite. So the total pressure of the system is less than that of the less than that of the sum of partial vapor pressure of individual components. So in some liquid, vapor pressure is lower than that of the sum of the individual components, and this is called as negative deviation. In some liquid mixture, the vapor pressure of mixture is less than that of the sum of the partial pressure of the individual component. This is called as a negative deviation. So for example, chloroform acetone का मिक्सचर लेंगे तो इसका मान लीजिए कि पार्शियल वेपर प्रेशर इसका 1 है, इसका 1 है, तो टोटल वेपर प्रेशर कितना होना चाहिए सिस्टम का 2, लेकिन इसका 1 ही होता है. दैट मीन्स negative deviation. Okay, so total vapor pressure is less than that of the individual partial vapor pressure. Chloroform acetone is the system, pyridine acetic acid is the system, again water and nitric acid. ये examples भी आपको याद रखना है. Okay, so examples के ऊपर भी as it is question पूछ सकते हैं. So that is negative deviation. So वैसे तो distillation chapter आपके CVS ceremony में दिया है, एक थोड़ा सा एक 20 पेजेस का चैप्टर है, but actually GPAT के लिए उतने सब each and everything is not important, so we are taking just only whatever is important for GPAT. So positive deviation, negative deviation, इतना भी नहीं कम ले रहा हो कि मैं सुपरफिशियल नहीं ले रहा हूँ, सब कुछ प्रॉपरली ले रहा हूँ. ठीक है. नेक्स्ट वन इज द Dalton's law. This Raoult's law and Dalton's law are the basis for the distillation. Okay, so what Dalton's law state? The total vapor pressure exerted by a mixture of ideal gases may be considered as a sum of the partial vapor pressure exerted by each gas alone where present and occupy the total volume. मतलब उसका मतलब भी सेम ही है, but only Raoult's law is applicable for liquids and Dalton's law is applicable for gases. That's it. So according to Dalton's law, vapor pressure is equal to partial vapor pressure of component A plus partial vapor pressure of component B. Is the total pressure exerted by a mixture of ideal gas is equal to partial vapor plus of gas A plus partial vapor plus of gas B. This is known as a vapor composition diagram. Vapor composition diagram. This is vapor composition diagram for ideal mixtures of liquid. तो obey Raoult's law. तो उसमें क्या है कि this is a vapor pressure curve for A, this is vapor pressure curve for B, and this is the vapor pressure curve for mixture. तो इसमें क्या है कि vapor pressure of A plus vapor pressure of B is equal to vapor pressure of mixture. Raoult's law का मतलब ही वही ना कि total pressure of system is equal to nothing, is equal to partial vapor pressure of A plus partial vapor pressure of B. So that is a curve for ideal solutions or ideal mixture. Obey Raoult's law. Okay, this is a positive deviation. So यहाँ पे क्या हो रहा है ये देखो, it is a curve for mixture where total vapor pressure is more than that of the individual vapor pressure of component. So that's why it is a positive deviation. The Raoult's law. It is a negative deviation from Raoult's law. So the total vapor pressure per system is less than that of the vapor pressure of individual component. It is negative deviation. So it's just a simple distillation unit for distillation. यहाँ पे आपका ये distillation flask होगा. Okay, देन थर्मामीटर एंड ऑल दैट रहेगा आपका कंडेंसर और ये रहेगा आपका रिसीवर. Whatever material over here to be distilled is known as distillant. The after the distillation, the product is known as a distillate. So again, to the theory of volatility of component. एक component का volatility कैसे calculate करेंगे? Volatility of component A. So suppose that you have mixture of component A and component B. So individual volatility कैसे? So volatility of component A is nothing but the partial vapor pressure of A divided by its mole fraction in the solution. So volatility of component A is equal to partial vapor pressure of component A divided by mole fraction of component A in the solution. So that will give you volatility of component A. Now relative volatility. Relative volatility मतलब volatility of component A in relation with the component B. So relative volatility is given by volatility of component A divided by volatility of component B. Okay, there is nothing but the relative volatility. More will be the difference in the relative volatility, so more will be the efficiency of distillation will be the more. ये difference कम हो गया तो distillation के लिए भी efficient नहीं हो जाएगा उतना, मतलब you will not get a pure product. तो यहाँ पे ज़्यादा difference है volatility में, distillate कर सकते हैं. Now there are two kind of mixture. Zootropic mixture. Zootropic mixture means liquid with a different boiling point. Liquid nitrogen, methane, ethane हो गया, propane हो गया. Then benzene toluene का mixture हो गया. So these two have different boiling points. Tetrachloride cyclohexane का mixture हो गया. So these two have different boiling point. Carbon tetrachloride का अलग है, cyclohexane का अलग है, water का अलग है, methanol का अलग है. तो ये water methanol का system है. So these are known as zeotropic mixture and they are easy to distillate. Okay, zeotropic mixture they are easy to distillate because they have different or wide difference in the boiling point. Azeotropic mixture. What do you mean by azeotropic mixture? They are also known as a constant boiling mixture. इसके बारे में GPAT 2019 में as it is question पूछा. So those mixture which boils at a constant boiling point, they are known as azeotropic mixture. Okay, constant boiling mixture because vapor has the same composition as a liquid mixture. ये मैं explain करता हूँ. Azeotropic mixture मतलब क्या? They are known as a constant boiling mixture because vapors have the same composition as the liquid mixture. For example, chloroform, acetone, pyridine, acetic acid and water nitric acid. These are the example of azeotropic mixture. तो मान लीजिए कि जैसे आप यहाँ पे डिस्टिलेशन चल रहा है आपका, ठीक है, तो इसमें क्या है एजियोट्रोपिक, मान लीजिए जूट्रोपिक मिक्सचर है. जूट्रोपिक मतलब जिसमें बॉइलिंग पॉइंट में डिफरेंस होगा. तो देयर इज डिफरेंस इन द बॉइलिंग पॉइंट ऑफ मिक्सचर. सो जैसे आप यहाँ सेट करते हो, एक का बॉइलिंग पॉइंट आ गया, वो फिर बॉइल होके वेपराइज हो जाएगा और वो वेपर आपका यहाँ कंडेंसेशन हो जाएगा. दूसरे का बॉइलिंग पॉइंट अभी आया नहीं है, तो यू कैन कंट्रोल द हीटिंग. दे आर इजी टू डिस्टिलेट. zootropic mixture. Now suppose that you have azeotropic mixture whose boiling point is near about the same. ठीक है, डिफरेंस नहीं जाता. तो क्या होगा, जैसे आप बॉइल करोगे दोनों के वेपर बन जाएंगे, लेकिन जिसका बॉइलिंग पॉइंट कम है उसके वेपर ज्यादा बनेंगे और जिसका बॉइलिंग पॉइंट ज्यादा है उसके वेपर कम बनेंगे. ठीक है, मतलब बट ये आप मिक्सचर ही बन रहा है ना, ये प्रोपोर्शन कम ज्यादा है लेकिन मिक्सचर ही. So these vapors are going to condensate and you are getting distillate, but this distillate will have mixture. Okay, mixture of the proportion will be higher proportion of higher amount of low boiling component and less amount of boiling component. So that is true in the azeotropic mixture. Azeotropic. Okay. It is not easy to distillate azeotropic. The composition they will form a same composition as like a liquid mixture. ठीक है, azeotropic मतलब उनमें कोई भी volatility में कोई भी उनमें ये नहीं है, डिफरेंस नहीं है. If they are having similar volatility, so they are not easy to separate. So they will boil and the vapor will also have same composition as like liquid. Liquid में क्या है, जैसे मान लीजिए 50% है तो वेपर में भी 50% आएगा. You will get a mixture again more. So it is not easy to distillate the azeotropic mixture, and that's why they are known as a constant boiling mixture. So again, types of distillation and the important points from each distillation. So we are not going to discuss over here the construction, working, advantages, disadvantages and all that. So that you can read from the book. Well, that is not important concept. But you should read it once. एक बार तो भी कम से कम आपने पढ़ना चाहिए. Types of distillation and important points. So first one is simple distillation. Simple distillation is also known as differential distillation. Remember, simple distillation is also known as differential distillation, and it is based upon the difference between volatilities and vapor pressure of the component in mixture. ओके, सिंपल डिस्टिलेशन के लिए आपको दो कंपोनेंट में डिफरेंस होना चाहिए वोलेटिलिटीज में या फिर उसके वेपर प्रेशर में. Construction and working and then advantage and disadvantage you can read from books. Okay? That is not in me. But during the distillation, so during the distillation, if you apply heat directly to the flask, so there will be bumping in the liquid. Okay, so that bumping can be avoided by addition of porcelain pieces. So that is, this point you might have seen in the 12th answer. Now flash distillation, another type of distillation is a flash distillation. Now, this is important. It is the process in which mixture of liquid enter mixture of liquid mixture of liquid is vaporized rapidly by passing through the liquid feed from high pressure zone to the low pressure zone. डिस्टिलेशन में क्या होता है, जो भी मिक्सचर आपको डिस्टिलेट करना है उसको क्या करना है, मिक्सचर हाई प्रेशर जोन से लो प्रेशर जोन में ट्रेवल जब करेगा तो उसका वेपराइजेशन होगा रैपिडली. सो फ्लैश वेपराइजेशन विल बी देयर इफ यू पास ए हॉट मिक्सचर ऑफ योर लिक्विड्स फ्रॉम हाई प्रेशर जोन टू लो प्रेशर जोन. ओके, कैसे होगा मैं बोलता हूँ आपको, डोंट वरी. नाउ हियर जस्ट रिमेंबर, flash distillation is nothing but the process in which entire liquid mixture which rapidly get vaporized by passing the feed into high pressure zone to low pressure zone, and this is also known as equilibrium distillation. So synonyms are very important. Remember, this flash distillation is also known as equilibrium distillation. Equilibrium distillation बोलते हैं इसको, ये याद रखो. Now it is used for the separating the compound which boils at widely different temperature. जिसकी टेम्परेचर का डिफरेंट टेम्परेचर का मतलब जिसका बॉइलिंग पॉइंट अलग अलग है या फिर जिसका डिफरेंस है बॉइलिंग पॉइंट में, तो उनके लिए यूज करते हैं. सो दिस इज यूज फॉर सेपरेटिंग द कंपाउंड व्हिच बॉइल्स एट अ डिफरेंट टेम्परेचर. फॉर एग्जांपल पेट्रोलियम इंडस्ट्री एंड रिफाइनिंग ऑफ क्रूड ऑयल. पेट्रोलियम इंडस्ट्री में फॉर द रिफाइनिंग ऑफ क्रूड ऑयल वो फ्लैश डिस्टिलेशन यूज करते हैं. फ्लैश डिस्टिलेशन अगेन अ सेपरेशन based upon the flash vaporization. A hot mixture is to be distilled or separated is passed from high pressure zone to low pressure zone. Pressure of low pressure zone or reduced pressure. You know that if you decrease the pressure, so the boiling point will also get decreased. Section of pressure will reduce the boiling point. Okay, and less if the mixture has a one compound which is a highly volatile and which is a less volatile. So highly volatile compound will get vaporized immediately. Okay, so that is the principle. So here separation is based upon the flash vaporization. Hot mixture is separated passing from a high pressure zone to low pressure zone. Because of low pressure it reduces the boiling point of which leads to vaporization of liquid. Energy for vaporization is taken from liquid itself, and because of that energy mixture gets cooled. Flash distillation, the mixture will get cooled. इसलिए आपको हॉट मिक्सचर यूज करना है. जैसे ही वो हॉट मिक्सचर हाई प्रेशर जोन से लो प्रेशर जोन में जाएगा, उसमें का जो दो कंपोनेंट है उसमें का एक कंपोनेंट में बॉइलिंग पॉइंट कम होगा, एक का ज्यादा होगा. जिसका बॉइलिंग पॉइंट कम है वो फ्लैश से ही सब, जैसे ही वो लो प्रेशर जोन में जाता है उसका वेपराइजेशन हो जाएगा क्योंकि उसका बॉइलिंग पॉइंट फर्दर डिक्रीज हो चुका है. ठीक है, सो इट विल गेट वेपराइज्ड. ओके, एंड दैट वेपर्स कैन बी कंडेंस्ड एट अनदर प्लेस. It is the principle involved in the flash distillation. Molecules in the vapor phase with low boiling point gets condensed and high boiling point molecule remains in the remains liquid, which later condensed and collected. I will explain it. Application of this flash distillation, refining of crude oil in the petroleum industry, and desalination of seawater. Desalination मतलब removal of salt from water. Desalination of seawater to get drinkable water from seawater for the navy. जो नेवी वाले जो होते हैं, नेवी वाले तो तक समंदर में रहते हैं तो उनका पानी का प्रॉब्लम सॉल्व होता है इससे. फ्लैश डिस्टिलेशन, इसको कंप्रेशन डिस्टिलेशन भी बोलते हैं. कंप्रेशन ऑफ हेप्टेन फ्रॉम ऑक्टेन इज आल्सो डन बाय फ्लैश डिस्टिलेशन. सो यू कैन सी डायग्राम ओवर हियर. तो जो भी मिक्सचर है आपका, मिक्सचर ऑफ कंपोनेंट इज फीड फ्रॉम दिस पॉइंट. ओके, सो दिस इज अ हाई प्रेशर जोन पे हीटर यूज किया जाता है. तो सो यू आर पासिंग योर मिक्सचर इनटू हाई प्रेशर जोन. तो ये यहाँ से लो प्रेशर जोन में जब जाएगा, यहाँ पे प्रेशर रिड्यूसिंग वाल्व में, यहाँ पे जैसे ही लो प्रेशर जोन में जाएगा जिसका बॉइलिंग पॉइंट कम है विल गेट वेपराइज्ड इमीडिएटली, और जिसका बॉइलिंग पॉइंट ज़्यादा है that will get condensed immediately. Okay, vapor यहाँ से condense कर सकते हो और जो जिसका boiling point ज़्यादा है वो liquid form में यहाँ से the distillation. One is a fractional distillation. Fractional distillation. The process it is the process in which vaporization of liquid mixture gives rise to a mixture of constituent from which desired one is isolated in a pure form. Fractional distillation is the distillation where you will get a pure distillate, relatively pure. मतलब ऐसा totally pure नहीं मिलेगा लेकिन relatively pure. Okay, fractional distillation is the process in which the mixture is vaporized. Okay, the liquid mixture is vaporized, which will give rise to a mixture of vapor plus liquid. Mixture of vapor plus liquid, which is then again condensed in the fractionating column. Okay, so that again that mixture will have less liquid content, more vapor content. Again same vapor get entrapped into another fractionating column, fraction of the column, and where again a more vapor and less liquid will be the composition. So I will explain this. Fractional distillation is the process in which vaporization of liquid mixture gives rise to a mixture of constant from which desired one can be isolated in pure form. This is also known as a rectification. Fractional distillation is also known as a rectification, and fractionating column is used in this distillation. Also used for the separation of miscible liquid. जो distillation थे आपके flash distillation, simple distillation, kind of distillation they are used for the miscible liquid. ठीक है, immiscible liquid जो है partially miscible liquid जो है उनके लिए miscible liquid fractional distillation is used for separation of miscible liquid, for example acetone and water, chloroform and benzene. तो इनका अगर distillation करना है तो fractional distillation. फ्रैक्शनल डिस्टिलेशन डिफर्स फ्रॉम सिंपल डिस्टिलेशन. सिंपल डिस्टिलेशन में क्या होता है कि आपका मिक्सचर आप वेपराइज करोगे और उसका वेपर कंडेंस करोगे एक ही टाइम पे होता है. वंस you are just vaporizing the mixture and condensing the vapors at once. But in case of fractional distillation, this process is repeated. So in the very first slide I have told you. So vaporization, condensation, they are repeated. The pure vapors, relatively pure vapors of component. So that is nothing but the fractionation. So you are getting a fractions over here. तो पहले फ्रैक्शन में क्या होगा, पहले फ्रैक्शन में आपका लिक्विड प्लस वेपर, तो उसमें थोड़ा बहुत लिक्विड होगा, ठीक है, और वेपर होगा, तो उसमें थोड़ा सा पार्शियल कंडेंसेशन होगा वहाँ पे जो कॉलम में है, जो फ्रैक्शनेटेड कॉलम है उसमें पार्शियल कंडेंसेशन होगा. तो जो वेपर है उसका जो पॉइंट कम है तो वो वहाँ से निकल जाएगा. दूसरे फ्रैक्शन में क्या होगा, तो उसमें जो लिक्विड है वो कम रहेगा, उससे भी वो लिक्विड वहाँ पे कंडेंसेशन होके वो लिक्विड डायरेक्टली आपके मिक्सचर में आ जाएगा और वो जो वेपर है वो प्योर वेपर आपको कंडेंसर में जाएगा. सो दैट वेयर you can condense pure vapor. Differs from the simple distillation that fractional distillation, number of times liquid is vaporized and condensed. Simple distillation is suitable for the mixture containing it is not suitable for the mixture containing similar volatilities. Resulting distillate is more concentrated from one more volatile compound than original mixture. ठीक है, सिंपल डिस्टिलेशन क्या होता है, बिकॉज ऑफ डिफरेंस इन द वोलेटिलिटीज द डिस्टिलेशन इज मोर concentrate about one product component A and B है, तो जो लेस वोलेटाइल है या फिर जो जिसका बॉइलिंग पॉइंट कम है वो ज़्यादा में डिस्टिलेट में मिलेगा, लेकिन उसमें कुछ हद तक आपका कंपोनेंट बी भी मिलेगा. फ्रैक्शनल डिस्टिलेशन में ये नहीं होता. फ्रैक्शनल डिस्टिलेशन इज यूज्ड टू गेट अ relatively pure form of distillate. Simple distillation is suitable for mixing a mixture of containing similar volatilities, and resulting distillate is more concentrated form, more volatile component than original mixture, but it may consist of a significant amount of higher boiling point component. Okay? So if simple distillation is carried out repeatedly, it will give you more concentrated form of compound with low boiling point, which decrease the amount of higher boiling point. Compatible with the fractionation. The fractional distillation is the process in which vaporization of liquid gives rise to the mixture of constituent from which desired one can be separated in a pure form. It is also called as rectification. Method is used to separate the miscible volatile liquid whose boiling points are close by means of fractionating column. जो ऊपर पे लिखा है सेम थिंग here. Liquid with similar boiling point are separated treating the vaporization and condensation using the fractionating column. The fractional distillation. Fractionating column, partial condensation of vapor is allowed to occur. That less boiling point component will get condensed and returned to the still, and leaving relatively fewer vapors to pass to condenser. Okay. Efficiency of fractional distillation, इसके ऊपर भी कभी कभी क्वेश्चन आ सकता है. Efficiency of fractional distillation is given by McCabe-Thiele theory. Cabet-Thiele theory. So this theory will explain you the efficiency of fractional distillation or efficiency of fractionating column. जो fractionating column होता है उसका efficiency कौन देता है? ये theory, McCabe-Thiele theory. ये इतना याद रखो कि McCabe-Thiele theory is related with the efficiency of fractionating column. Is related with the fractional distillation. इतना भी याद रखा आपने, आपका काम बन जाएगा. नंबर ऑफ ओके, तो जैसे नंबर ऑफ थ्योरेटिकल प्लेट्स कि नंबर ऑफ हाइपोथेटिकल जो नंबर ऑफ हाइपोथेटिकल प्लेट्स जहाँ पे कंडेंसेशन होता है, पार्शियल कंडेंसेशन, उसको बोलते हैं नंबर ऑफ थ्योरेटिकल प्लेट. इट इज यूज्ड टू इवेल्युएट द एफिशिएंसी ऑफ फ्रैक्शनेटिंग कॉलम. Height equivalent to theoretical plate is equal to number of theoretical plate divided by height of each or distance of that fraction. Explain करता हूँ यहाँ पे. Application of separation, applications क्या है इसके fractional distillation के? So fractional distillation is application. It is used for the separation of miscible liquid like acetone, water, chloroform and benzene to separate the mixture when boiling point of mixture is intermediate between those of pure constant. The application. So you can see here, this is a for fractional distillation. So this type of column is known as fractionating column. देखो एक यहाँ पे ऐसा fractions लगा है. So initially जो आपका मिक्सचर है, मिक्सचर वेपराइज होगा, यहाँ पे आएगा, तो उस मिक्सचर में क्या होगा कि जो मोर वोलेटाइल कंपोनेंट है उसका तो वेपर हो जाएगा, लेकिन जो लेस वोलेटाइल कंपोनेंट है उसका भी मिक्सचर आएगा, बिकॉज ये मिक्सचर में डिफरेंस नहीं है ज़्यादा बॉइलिंग पॉइंट में, तो दोनों का कंपोजिशन आएगा. तो यहाँ पे वेपर जब आएगा तो यहाँ पे पार्शियल कंडेंसेशन होगा, कंडेंसेशन. सो द मिक्सचर व्हिच इज हैविंग हायर बॉइलिंग पॉइंट विल बी कंडेंस्ड ओवर हियर एंड विल रिटर्न टू मिक्सचर, बट द वेपर विल पास थ्रू सेकंड फ्रैक्शन. ओके, सो सेकंड टाइम में क्या होगा, ये वेपर में उसका कंपोजिशन कम होगा, इसका हायर बॉइलिंग पॉइंट वाला जो आपका कंपोनेंट है उसका कम होगा, बॉइलिंग पॉइंट वाला उसका ज़्यादा होगा, लेकिन कुछ होगा ना वहाँ पे, तो वो जो बचा है वो भी कंडेंसेशन होकर यहाँ पे आएगा. तो वैसे तक आते आते जो आपका लेस आपका जो लेस बॉइलिंग पॉइंट वाला मिक्स जो कंपोनेंट है उसका प्रोपोर्शन ज़्यादा रहेगा इसमें, यहाँ तक आते हैं पे प्योर फॉर्म में आपको फिर मिलेगा. दिस तो जो पहला जो मिक्सचर होगा वेपर और लिक्विड का मिक्सचर, तो वेपर किसका, द कंपाउंड हैविंग लेस बॉइलिंग पॉइंट, और लिक्विड किसका, कंपाउंड हैविंग मोर बॉइलिंग पॉइंट. तो इसका जो कंपोजिशन है इसमें ये देखो, इसमें यहाँ तक ज़्यादा रहेगा, ठीक है, यहाँ तक, यहाँ का ये है वेपर वाला, ये है लिक्विड वाला. तो लिक्विड वेपर इक्विलिब्रियम यहाँ पे फर्स्ट फ्रैक्शनेट पे ज़्यादा रहेगा, सेकंड फ्रैक्शनेट पे वो कम होते जाएगा, यहाँ पे कम होगा, यहाँ पे नील होगा, ठीक है. मतलब यू आर गेटिंग अ दिस वेपर इज अ प्योर वेपर कंटेनिंग ओनली compound having less boiling point. Okay, so you are getting a pure distillate over here. Okay, boiling point curve for liquids, ठीक है, boiling point curve for miscible liquids. ये हो गया आपका लिक्विड एक कंपोनेंट ए कंपोनेंट बी, ठीक है. जैसे यहाँ पे 0% ए का है, 100% बी का है, यहाँ 0% ए का 100% है. नाउ द अपर कर्व इज नोन एज अपर कर्व इज नोन एज वेपर कर्व एंड बिलो कर्व इज नोन एज लिक्विड कर्व. मतलब जो कर्व है ये टेम्परेचर रेंज में क्या होगा कि दोनों का मिक्सचर जो है वो लिक्विड फॉर्म में रहेगा. ये ऊपर वाला कर्व में ये टेम्परेचर पे क्या होगा कि दोनों का ये टेम्परेचर रेंज में दोनों का भी मिक्सचर में वेपर रहेगा, ठीक है. सो वेपर कर्व, लिक्विड कर्व. एट दिस टेम्परेचर योर कंपोनेंट बी गेट्स कन्वर्टेड टू वेपर, ओके, एंड एट दिस टेम्परेचर your component A gets converted into vapor. That means there is a difference between the point of vaporization or boiling point between A and B. This is for ideal or ideal or miscible mixture. This is curve for miscible mixture, and this proportion, this is a mixture of vapor plus liquid. ये दोनों के बीच में मिक्सचर है. अगर टेम्परेचर ड्रॉप होता है तो यहाँ पे लिक्विड बन जाएगा. यहाँ पे मतलब ये टेम्परेचर है जहाँ पे एक कंपाउंड वोलेटाइल है, दूसरा नहीं है. इट इज इजी टू डिस्टिलेट सच काइंड ऑफ मिक्सचर. ऐसा मिक्सचर है तो इजीली डिस्टिलेट कर सकते हैं. बट ड्रॉप कैसे होता है एजिटॉप दिखा. सो बॉइलिंग पॉइंट composition curve for constant boiling azeotropic mixture having minimum boiling point. देखो इसमें कंपोजिशन जो है वो दोनों भी सेपरेट है ना. इसमें क्या होता है कि एजियोट्रोपिक सॉल्यूशन में क्या होता है, एजियोट्रोपिक मिक्सचर में. सो एजियोट्रोपिक मिक्सचर में मान लीजिए कंपोनेंट सी है और कंपोनेंट डी है, दो का मिक्सचर है एजियोट्रोप. ओके, सो व्हाट हैपेंस इन दिस. सो when temperature at which component C gets vaporized, okay, at that temperature, that is a vapor curve for component C. This is a vapor curve for component C, and this is a liquid curve for component C. Okay, okay, for both mixture. Now at this there is only 50% composition. तो 50% A का वेपराइज होगा और 50% B का वेपराइज होगा, मतलब C का और D का. तो इसमें दोनों भी कंपोनेंट आएंगे. तो इसमें क्या है कि there is no difference between the boiling point of component C and component D. Difference नहीं है. Okay, that's why the composition remains same. So if you increase the temperature, again the composition remains same. They are known as a boiling mixtures. They are known as constant boiling mixtures, or they are known as azeotropic mixture. Azeotropic solution is the solution which distill unchanged at a constant temperature. टेम्परेचर कितना भी करो आप, वो उसका कंपोजिशन सेम रहेगा 50-50%. also known as a constant boiling mixture. ये GPAT में क्वेश्चन आ चुका है. To separate them, azeotropic distillation method is used. Azeotropic distillation method. So it is a distillation method in which azeotropic mixture is broken by addition of third substance, which will form a new azeotrope with one component and leaving one component free for distillation. Nothing but the azeotropic distillation. Extractive distillation is another method. Substance added to break the azeotrope. Third substance added to break the azeotropic mixture is relatively non-volatile as compared to component to be separate. That happens in the extractive distillation. कुछ नहीं है, बस जो थर्ड सब्सटेंस ऐड कर रहे हैं यहाँ पे वो नॉन वोलेटाइल होगा, यहाँ पे वोलेटाइल होगा. So as it to break the azeotropic distillation mixture, you add a third substance, volatile substance. Third volatile substance. Volatile substance will form an azeotropic mixture with either one component, leaving other component free for distillation. So that is nothing but the azeotropic distillation. So to absolute alcohol, azeotropic is a distillation under reduced pressure. So you know that pressure अगर कम करेंगे तो boiling point क्या होता है, कम. Vacuum is applied in the distillation under reduced pressure. So apparatus used is a Claisen flask, where double neck distillation flask. Claisen flask is a double neck distillation flask. उसको दो गर्दन होगी. एक गर्दन को आपको वैक्यूम लगाएंगे, एक इसमें ये आपका कंडेंसर लगाएंगे. So distillation under reduced pressure is also known as a vacuum distillation. It is also known as vacuum distillation. So application of external pressure will increase the boiling point, whereas the removal of external pressure will decrease the boiling point. Okay, so that is the principle utilized over the distillation under reduced pressure. तो यहाँ पे वैक्यूम लगाएंगे तो जो मिक्सचर का बॉइलिंग पॉइंट है वो कम होगा, okay? और वो जल्दी वेपराइज हो जाएगा. So this vacuum distillation or distillation under reduced pressure is used for a heat sensitive product and the mixture with low viscosity or foamy liquids. Foamy liquid mixture, कि दो मिक्सचर अगर फॉर्म बना दे तो उसको वो मिक्सचर और लो विस्कस मिक्सचर है तो distillation under reduced pressure. Next one is a molecular distillation. So it is a distillation process in which molecule in vapor phase travels a short mean free path and gets condensed individually without intermolecular collision upon the application of vacuum. Okay, so it is nothing but the type of short path vacuum distillation. It is a type of short path vacuum distillation. कि vacuum distillation जो बनाया देखा है अपन ने, डिस्टिलेशन अंडर डिस्टिलेशन उसका ही टाइप है मॉलिक्यूलर डिस्टिलेशन. ओके, बट यहाँ पे जो वेपर जो ट्रैवल करते हैं उसका जो कंडेंसर होता है वो कंडेंसर बहुत ही शॉर्ट होता है, एकदम शॉर्ट, 2 सेंटीमीटर. So it is a type of short path vacuum distillation at extremely low vacuum pressure 0.001 torr. इसका जो प्रेशर वैक्यूम है वो बहुत ही कम वैक्यूम लगा, मतलब बहुत ही लो वैक्यूम प्रेशर रहता है. A short term exposure of a short term exposure on distillate liquid to high temperature and high vacuum in the distillation column and small distance between evaporator and condenser. evaporator and condenser के बीच में एकदम शॉर्ट डिस्टेंस होगा और यहाँ पे हाई वैक्यूम लगाएंगे. ओके, सो दैट इज द मॉलिक्यूलर डिस्टिलेशन. ओके, so there is one equation related with this molecular distillation known as a Langmuir-Knudsen equation. Langmuir-Knudsen equation that describes the efficiency of molecular distillation, that describes the yield of distillate for molecular distillation. So what is that equation? That equation is the Q is equal to K into P into F into M divided by T raised to half. What is Q? Q is nothing but the quantity of distillate, or quantity of evaporated liquid, gram per hour. Okay, P is nothing but the pressure, T is the absolute temperature, M is the molecular weight of individual component, F is the surface area of evaporation, and K is the constant. यहाँ पे इतना याद रखो, just remember this Langmuir equation is related with the efficiency of molecular distillation. Now again steam distillation. Next method is steam distillation. Method used for separation of higher boiling substances from non-volatile impurities. With the high boiling point usually boils at a lower temperature when mixed with the steam. होता है कि मान लीजिए सबस्टेंस है जिसका बॉइलिंग पॉइंट ज़्यादा है, मान लीजिए उसका बॉइलिंग पॉइंट 1 डिग्री सेल्सियस है, उसका मिक्सचर किया स्टीम में, molecular distillation. Just remember Langmuir-Knudsen equation is used to describe the yield of distillate for molecular distillation. Equation is that steam distillation. So steam distillation is used for those substances which has a high boiling point, but when they are mixed with the steam, their boiling point get reduced. Okay, now they can boil at the lower boiling point. Okay, so this phenomenon is used to isolate the volatile oil present in the various crude drugs. The extraction of volatile oil from crude drugs was the last process for. Next one is the destructive distillation, which is also known as a dry distillation. Destructive distillation, dry distillation is also known as a destructive distillation. इसमें destruction हो जाता है product. So distillation method in which distillate is a decomposition product of constituent, one of the constituent of organic matter, which is burnt in the absence of air. तो destructive distillation के बारे में GPAT में क्वेश्चन पूछा. Compression distillation is a method developed to meet the needs of army and navy for fresh water, which is obtained from sea water. So compression distillation is nothing but the जो मैंने बोला है आपको about the distillation. See, you can see pharmaceutical engineering by CBS सुब्रमण्यम. आपको डिस्टिलेशन का वो सब पार्ट जो भी है वो सब कवर किया है.